In this video, we will be learning about the formation of ionic compounds by alkali metals. Alkali metals are the group 1 elements. They are lithium, sodium, potassium, rubidium and cesium. Do they form ionic compounds? Yes. These group 1 elements have the valence shell electronic configuration as ns1, and we know that this valence electron is weakly held with the nucleus. As a result of that, it can be easily lost by the alkali metals to form M plus ion, that is the cation, where M is the alkali metals. Hence, the alkali metals can transfer this valence electron to the most electronegative elements, and let us denote that one by A. They can transfer their valence electron to the most electronegative element to form an ionic compound. So M plus with A minus, we get an ionic compound of the alkali metals. Your A here is the electronegative, this A, okay, is your electronegative elements. To be more clear with this, we have an example. Say sodium, okay, sodium is an alkali metal. The atomic number is 11, electronic configuration is 281, so it has one valence electron. Sodium loses this valence electron to give sodium plus, and then this one electron can be transferred to an electronegative element, say Cl, to give an ionic compound, sodium chloride. In this way, an ionic compound is formed when sodium reacts with an electronegative element, chlorine. Okay, so this is how the alkali metals form ionic compounds. Similarly, lithium with Cl2, we have lithium chloride, okay, and so on for the other elements. Now, what about the ionic character as we move from top to bottom along the group 1? If we move from top to bottom, the ionic character increases. Why? Because as we move from top to bottom, the size of these atoms, for lithium small, and then it becomes big for sodium, and then larger and larger, and so on. As we move from top to bottom along the group, the size of the atom increases. So when the size of the atom increases, the ionization energy or enthalpy decreases. If the ionization energy decreases as we move down the group, then these elements can easily lose their one valence electron to form M plus cation. Okay, that is, the ionic character increases as we move from lithium to cesium, or in other words, we can say that the compounds formed by cesium is more ionic than that formed by lithium. Similarly, the compound formed by sodium is more ionic than that formed by lithium. For example, sodium chloride and lithium chloride, which one is more ionic? Obviously sodium chloride, because the size of sodium is larger, okay, as compared to the size of lithium. Smaller the size implies more polarizing power of the cation. Hence, more the polarizing power of the cation, more is the covalency. That is, lithium chloride is more covalent than sodium chloride, and sodium chloride is more ionic than lithium chloride. In this way, we can compare the ionic character of the compounds formed by the alkali metals or the group 1 elements from lithium to cesium. So that's all about the ionic compounds formed by the alkali metals.